Hello, everyone. My name is Honchar, and here in this speech, I want to talk about the topic that is very controversial and in a way doesn't even make any sense. But I hope in a couple of minutes from now, you'll see actually how much sense it does make and how beneficial it can be in your own practice and applications of AI, machine learning, and data science. I've been working in this field basically all my conscious professional career. Started working with different small ventures, startups, helping them to create things from the very, very zero when there is no data present, no solutions, no validated market fit, but we had to go somehow and bring it to the market. And as well work with the bigger ventures, mainly in the investment management field. And there is a lot of processes, a lot of benchmarks, a lot of standards, a lot of data, a lot of competition and you need to stand out there as well using the main topic of the today's speech, data science, machine learning, and the main narrative in the market that we observe, that we see, some of us like, some of us don't, is about the big data. And all the cloud providers, they're happy to host the big data, they're happy to promote it because they're one of the main beneficiaries of this trend. Of course, the makers of the graphic processing units and other supercomputers that also are really happy to process the data using the heavy lifting algorithms. And it looks like without the data, without the big data, you cannot build the AI products, you cannot do the data science. And the question is, how can you hack the system, especially if you're a startup, especially if you're a young venture, especially if you're the spin-off or doing something really complicated where you cannot amass a lot of data simply physically. And another part of this narrative is that's also really well promoted, which is also not necessarily true, is so-called data flywheel. Like you can get more users, collect more data, you build better algorithms, and somehow automatically you get better product that also drives more users. This is not really the case, because if you look at the illustration on the right, the most of typical users, they're coming in so-called fat heavy distribution of the different situations, processes, examples, and data pieces. But actually, most of the data, like in case of the search traffic, 70%, is some situation that doesn't really happen often. They belong to the long tail, rare, weird, interesting, non-standard situations that big data doesn't really cover. And this is the real distribution of the data. And this is breaking the data flywheel, which is again promoted by the bigger players. And this is the situation we observe mainly in the startups that are arising around big digital data, tabular data, a lot of images, natural language processing, internet scale data, million users, and trying to optimize some relatively simple routine process. And we can somehow get the two worlds of the AI here, which one is kind of traditional, is a digital world of bits and bytes, where we want to automate some routine tasks, maybe some recommendation systems, maybe just checking the internet messages with the natural language processing, maybe understanding the speech of people, which can give us linear boost of productivity. Basically, the more time you save, this is how you linearly boost or save boost the revenue or save some expenses. And the people who are building these kind of solutions, they're like people with the really business background. They understand the patterns, understand the data, and they create it for the regular people or users. And the developers who are integrating the AI solutions, they're basically creating them. And of course, it's all around the massive data, relatively standard algorithms that are actually commoditized. And there is a single optimization criteria, let's say accuracy, speed, this kind of stuff. And also there is the second cluster, which is much less known, but I would make an argument much more interesting. It's about physical world. It's about atoms and molecules. It's about physics, biology, chemistry, healthcare, energy, utilities, defense, automotive, and basically, let's say, real sector, real physical world. And the tasks that we are solving there are usually more scientific. It's the predictive maintenance, drug discovery, uh, aut- automotive driving cars. It's, let's say, more into engineering, more into expertise, and the boosts are non-linear. Take predictive maintenance. The earlier you can find a problem in your physical asset, then non-linearly is coming the saving of the costs. Since the process is technical and complex, often scientists and experts are founders. They creating such solutions for the also expert and scientific users, and developers also have to be scientifically and expertise heavy. You cannot just come and integrate some simple, not custom algorithms. And since data is expensive to obtain, you usually have not a lot of data, have to develop custom algorithms, and there's a lot of optimization criteria. You need to take into account the constraints of the physical world, since it's not just about bits and bytes in the internet. And we need to understand that if you talk about the data science, machine learning, and AI, and some kind of automating the cognitive processes, we can go two ways. One way, this is something what was happening before the digitalization, before the informatics age. You're observing some correlative relations, building empirical laws, and turning them into physical laws. Basically, that's how our science is still actually working. Now there is arising the second way to learn from the data and actually automating understanding things. Basically, machine learning, starting with the small data, ending with the big data. And the first way is forgotten today, but we still can reapply it very often in very many situations, actually building AI products. And this is very common to it. I'll start with the things that you can do with the digital products. Imagine you're building a tool for recommender systems and you want to engage people and recommend them something, give them some discounts, basically make them stay on your digital platform, but you have a cold start problem. It's a new system. You basically just start getting new customers. You don't have a big data to learn from. So basically, what you can do in this case, one answer is, oh, I just need to wait for the more data to accumulate. Well, you can, and in the long term, it might be the good case, but you need to compete now. You need to provide better service to your customers now. You have competitors. You have competitors maybe with more data than you, and they're competing with AI. So what can you do? There is a class of solutions, and some examples of such solutions are multi-arm bandits, active learning, reinforcement learning. If you have a set of different recommendations or set of different offers you can put on your website, you can start sampling them randomly into different buckets of customers. And you can basically just see in which bucket people reacted better. And this way you can adjust your recommendations, adjust your actions you can do with the customers, and learn from it purely statistically on the real customers in the real time. Yes, with some you will fail, but better than doing nothing. But when you will discover the bucket is working really well, you can scale it across your organization and already have the profit from it without actually collecting a lot of data, which might take a lot of time to collect it, organize it, store it, and work with it. Another thing you can do with the digital products is something what is, I would argue, more cool, more popular today. We all hear about these so-called foundational models all the time. This is DALL-E model that can generate images just from the textual description. For example, in the illustration here, you can see how with the text input, a chair in the avocado style, you can generate such weird and interesting chairs. There is GPT-3 that is able to generate high fidelity, reality looking texts. And there is also recent development called Whisper that actually is state-of-the-art solution for the speech to text and text to speech, which also can be used for different tasks. And the coolest part about this solution is that they are already trained on a lot of data, internet scale data for you. And you can use those solutions and adapt them really easily without retraining for your own purposes. For example, you can take solutions for computer vision like this that are already trained on the internet scale data sets, and you can easily ask them in the textual human comfortable form, recognize what the object is. Is it happy or is it sad face? Is it a damage or it's not a damage on the image? And those internet scale models, foundational models, they can give you a quick start with computer vision just by using those text prompts. The same with GPT-3 and similar models. Instead of training your own solutions, for example, for the sentiment analysis or for the question answering, you can just plug GPT-3 or similar model and ask it to generate a dialogue. And it will work well as a cold start solution. And since recently, you can do the same in the voice analysis, speech recognition tasks. Now let's come to a bit more complex area where zero data and no data is, let's say, even much more typical. When data is coming, for example, from the medical devices or wearable devices. Imagine you're a startup and you want to analyze different heart conditions, and you can have your wearable bracelet or you can have other medical device, but you have not accumulated any data yet. And let's say your data and your device is really custom, you have some innovation, and what you have to do, you can just either wait till you collect the data, but again, you have competition, and you need to go to market and actually test your startup ideas. So what you can do, you can apply the rules that are already studied by scientists for years. For example, on the illustration on the left, you see how different cardiac patterns you can discover from the heart rate variability. Those patterns are purely geometrical. So basically, you can code this geometry that is based on the human knowledge, on the scientific papers and books, and already analyze the heart conditions. If you want to go deeper into medical diagnosis, and if you can measure the actual ECG signal, you also can find so-called fiducial points, and you can find them using the geometry instead of applying like machine learning, going to the cloud, training something on the GPUs, deep learning. You can rely on the geometry and rule-based systems. And this is basically distilled knowledge of the human intelligence. And this is falling into the same category, but this is an example that I really like to tell. That some dozens of years ago, we could land on the moon without GPUs, without cloud, without neural networks, without deep learning. This was a big human achievement. And now we are trying to put for some simple tasks, how to recommend things on the website, all these novel algorithms and infrastructure. But basically, we can use some things as a Kalman filter, for example, to navigate drones, to navigate rockets. We can use it in defense. We can use it in the automotive industry, which is basically relying on the mathematical modeling. And the same can apply in the energy and utilities field, where we can basically take a physical asset, as for example, the photovoltaic model, and in order to build predictive maintenance solution, yes, we can collect data, we can train the machine learning model, but also we can read a couple of books about science, actually code the mathematical model as it is with the parameters, and based on the how parameters are changing, identify using our knowledge if it's fault or not, and when it's going to fail. Again, it might be not perfect, and on scale, if you have a lot of data, hundreds of thousands, millions of samples, of course, I encourage you to go with the machine learning, deep learning approach. But we're talking about the cold start. And the cold start is a cold start because you have nothing and you still have to compete. You still need to give value to your customers, need to give value to your investors, and you need to conquer the market. And those are the ways that you can go with. And this is a quick summary, some takeaways home if you want to remember just a couple of things and try it with your own team, in your own startup, for your own spin-off, in your own solutions. When you have no data and you want to go quickly, test quickly, not to waste a lot of time, not to spend a lot of money, you testing the ideas, I recommend you these 4 general groups of approaches called start solutions. If it's digital, mass people, routine tasks, try foundational models, try sampling, for example, with multi-arm bandits. If it's complex and physical and requires expertise, go with mathematical modeling, go with rule-based heuristics, go with physics-aware machine learning. You can visit the website of our company, Neurons Lab, to see how we already applied those solutions with the startups and bigger ventures. And don't hesitate to text me whenever you can find me in order to discuss those approaches and solutions more in depth. Thank you very much. And I hope this topic and these approaches can help you to build your own AI products much faster, much cheaper, and better for your customers. Thank you very much.